Hello, my name is Justin, and I'm with Vertispan. Today is May 18th, 2023. Today, I went ahead and ate lunch a little bit early so that I don't have to take a break in an hour. Probably too early to eat my lunch, but that's fine. So in between the streams, I started investigating other databases such as MongoDB for dealing with indexes. Let me go ahead and bring up my screen, and I was playing around with the MongoDB Compass application. I created a database, MongoDB database, on the MongoDB cloud, whatever it's called, just to play around with, just to see what I had. I did create a lot of data. So if I just search for all of the other documents, I can see that it matches essentially what I've been testing with my stuff, with the first name, last name, and age. So let me move that to the side. And what I did, I went to this website. I think it's called Makaru data generator. Yeah, this one right here. So I was able to basically create 1,000 records. I think that with the free, without upgrading, you can only export 1,000 records. But I created a CSV file with first name, last name, and age. And I went ahead and put it in here as mock data. It's a CSV file, just random data, 1,000 records. So there's 1,001 rows, because the very first row is the header. And I went ahead and started creating a test case for some of the work that I'm going to be doing with indexes. And this is basically just reading the CSV file from the other resources, and I'm just mapping it to a person object. And this is a local person. This isn't the person that I've been playing around with the app, since this is in the core. I didn't have access to it, so I just went ahead and created one specifically for this unit test. That way, if we ever need to change anything about it, we'd be able to do that in isolation without impacting everything on the outside. So then it basically reads all of the lines. I skip the very first line. I split each line based on a comma. And again, this is a poor man's CSV parsing. I knew what my data was going to be. I didn't have to escape anything like quotes or double quotes. And then I just create a new person. I'm parsing at the third column, which is the integer. And for each one of those, I'm adding it to a BTree. And I think I use 10 degrees as my default. And that's basically just adding all of that stuff. Might be changing the key in the stream. But we're going to take a look at that. So whenever I print out, let me see if I can find that tab. Whenever I print out the graph viz document of all of the connections here, you can see that it's quite large with 1,000 nodes. Each one of these can get up to 10 keys per node. So that's what this looks like. Probably won't be referring to that. We're going to assume that it works correctly because of the unit test that we did on the BTree itself. So probably just going to leave this at that and not touch that anymore. So the first thing that I want to do, basically I want to be able to create indexes such that I would be able to do a nice search without having to search all 1,000 records. So let's take a look at the MongoDB again. I am going to drop this index that I created here and come over here. And if I type a query, I was testing with, not recall who I was testing with. I should probably create a method in here to count the names, because I am not entirely sure how many common first names there are. So let's go ahead and do that. Private void count names and map. And this is going to be a string to an integer because I need to keep a tally. I don't know if that's how you spell tally, but I'll just do that. And I have a person list because not only did I add the items to the BTree, but I also added them just to a plain array list in the order that I found them. So it's all natural order because I wanted to be able to do maybe some comparisons for looking up records. How long does it take whenever I'm searching all 1,000 records? I mean, because this is a unit test, we're talking like milliseconds, so we're not going to be able to see a huge difference until we get upwards to like 500,000 to 1 million records. But this is fine. So for each one of those, we have a person, and we have a the tally, compute, and person first name is going to be the key for this. And I have the entry here. If the value is null, I just want to return a 1. Otherwise, it's going to be the value plus 1, and that's what we're going to compute as the value for each person. And we could probably just see which one has a lot of people in it. So let's take a look at this tally. Let's grab the entry set. Let's stream that. Let's filter where the entry value is greater than or equal to 3. And let's just system out this. Print line. There we go. Let's just see what this looks like. So before we do any of that, we're going to want to count the names, and let's go ahead and execute this. I did zoom in a little bit. Maybe that'll help with how much can be seen. All right, so looks like we have Noreen and Robbers. Is it supposed to be Robbers? Kind of an interesting name. Haven't heard that one before, but looks like those two have 3 people. So we should be able to at least find probably Noreen. We'll just use Noreen as our example here. And basically need to figure out how to, from a BTree, limit the range. All right, so let's go back over here. Oops, to the Mongo stuff. And because I used the same data in my CSV, all I did was import it as a CSV into the my test drive of MongoDB. But here I should be able to search for Noreen. And then whenever I click on find, we can see that we have 3 records. Sure, this did come in rather quickly. We have Noreen, age 12, Dummeril, age 46, and Witherspoon, 93. And if we click on the explain plan, we can see that we had to examine 1,000 documents just to get this to return our result, which means that because of the fact that it didn't have an index that matched our search, it had to do an entire collection scan. And that's what we typically do with most GWT components, like combo boxes and stuff, where we're actually looking through a data store for something. We're actually inspecting all of the other collections, and I'm hoping that with the work that I've been doing, we can bypass that and index the data in such a way that we reduce the number of records that we actually have to look at. So let's go ahead and create an index, and I'm going to create it the same way that I'm planning to in our testing purposes. So in here, we can see we have a first name. So basically has all of the index or the fields that are in this collection. And I'm just going to go on first name. And for the type, it looks like there's 4 different ones. We can just ignore the 2D sphere because I think that has something to do with geometry. If you have like a coordinate system in your database, you would be able to do certain types of indexing based upon the coordinates. Well, I did look it up. Let me see if I can find MongoDB documentation. Thank you. Let me open that URL. It looks like it's opening in the wrong browser. Earth-like sphere 2D index supports all MongoDB geospatial queries for inclusion, intersection, and proximity. So it does have to do with geometry, but I guess it's 3D, 2D sphere. I don't know. But long story short, I'm not going to even bother with that one. But the other two are important. The one that I'm concentrating on the most are the ascending and descending. Right now, I've hard-coded it to be ascending. I have no idea. I didn't look too much into it because I was hyper-focused on a specific what I was intending to work on. So honestly, I didn't really pay too close of attention to that. And then we also have text, which allows us to do the like comparisons, wildcard matching and stuff like that. Eventually we will do that, but I think for now I might just focus on the ascending and descending. So for this one, I'm just gonna do ascending for both of these. This is going to be age, and this is also going to be ascending. Yeah, I haven't touched it since 2018 or 16, something like that. I don't know. And even then, it was just the rudimentary of finding data in there. I didn't do anything complex. So whenever I create an index, this is basically going to create an index with it's a compound index, which is basically a key that represents both of these fields. So if we take a look at our key that we had, and this was the key that we were planning on using with the index. It has a compare to because the key is comparable, and this is going to be the key to the BTree. And then right here, we're basically, because we're calling A compare to B, we're always looking at the ascending side. We can swap this value to do descending. So I might actually recreate a brand new key. I'll leave this one alone because it's tied into the other index. But I'm probably going to rewrite some of this because I would like to be able to use this more in the JVM tests. But right now, because it's using like a JS object, or might be, yeah, I'm also using promises in here. That's not going to be very helpful on the JVM unit test. So I'll probably be replacing some of that stuff as well. And for the fact that you can have multiple types of indexes. We can even have like indexes that do intersections of each other. So you search for one field or multiple fields with index A, and then you search for another part in index B, and then take the intersection of both of those results, and that basically does like an and comparison. I think somebody might be mowing outside my house. Yep, mowers. All right. Yeah, it's kind of weird that mowers would be here since it was basically freezing temperatures overnight. But it looks like it's warmed up a little bit. What else do I have? I did actually find a bug with this compared to, because this is assuming that the other key values are the same length of this and other, which in one of the other cases that I was testing, they weren't the same length. So that was a poor comparison. Let's see. I think I've covered everything that I needed to cover before we actually start doing some work. So let's go ahead and figure out what we need to do. So let's create a new index. Let's call it index 2. Just because I'm not sure what it's going to be called at the long term. And this one will probably continue with static builders. I did like how I was doing the index over here. So here we had the db create index, and I am passing, which essentially this isn't creating the index. This is actually creating the index. The create index call was basically just adding the index to the database. So I might change this a little bit to make this more of a builder, because we may not know the type of index that we're going to create at this particular time. We may not know it until later down. So it might make sense for this to be like an index builder. Because if you remember from creating this index, we were able to specify the multiple fields, and for each one of those fields, we were able to select a type. I think there might be some options. I don't think we need to worry too much about that. We can give it an index name. I don't know how much we would actually need for the in-browser database, but let's before we get to that, let's go ahead and rerun the same search using the explain. And before it was doing an entire collection scan to find all of those records. But with this one, it was able to utilize index, and basically we only had to examine 3 documents, which is pretty cool. I'm not sure how. I'm assuming it's a BTree or something like that behind the scenes on the MongoDB side. I don't know to what degree, how many degrees are in each node. I'm assuming, I don't know. Because of the fact that we only needed to examine 3 documents, and we keyed it based upon the first name and the age. Even though we're only querying the first name, we were still able to find it. But if we were to do, let me age 15 and run that one. This one we actually had to examine 1,000 documents because we're not indexing specifically on the age. We were able to return 7 records, but because we have to search the first name, that's the only way it's going to be able to link it to that particular index. If I were to reverse these, if I went from, yeah, let me go ahead and do that. Let me drop that index and let's create a new one. This time, let's specify age first. And first name as ascending, create that index. If we were to explain that again, we only inspected 7 documents that time because we did the indexing on age. So that actually is very important to note whenever we actually come up with like a query planner. Eventually we're going to have to create a query planner so that whenever we're executing a find, it determines, does this query, if we take a look at our entry point, here's a find. Hopefully you guys can't hear the lawnmowers in the background. But we have the search and the selector, and this is where we're basically going to be able to add all of the operations. It will need to figure out, if we don't specify the index, how it's going to do that query. Is it going to do an entire collection scan because it doesn't match any indexes, or does it match an index and we can do it that way? So eventually we're going to have that. For the time being, we're not going to worry about that. Yeah, my neighbor, apparently they have a lawn service that comes every Thursday. Yeah, and they're getting closer to my house, even though our houses are pretty far apart. We have a shared driveway. All right, so we have this index, just creating a new one. Let's figure out how we can do this in a way where we can narrow down the search range, because that's the whole point of this. We want to be able to narrow down this search range so that we can more quickly identify which records to actually inspect. Because let's say that we did an index using a combination key of first name and age, and we did a search only on the first name, it would be able to at least create a start and an end key for our range that would make sense. So let's play around with that. We can actually do it here. This is what I was playing around before. There's Janika. I don't know. Which name were we planning on using? Noreen. Oops. Noreen. This one at least has 3 records. So let's see what this does. All right, so this one, I did modify the BTree. That's something that I did do. If I take a look at the search range on the internal node, I didn't want to get null pointer exceptions, so I allowed nulls to be passed in so that I can say, if the starting is null, then we want to start at the first leaf key, or if the end is null, we want to end it on the last leaf key. That way we know that there's not any kind of nulls getting into the children searches. And even in the leaf node, I had to do the same thing, because if the root node is a leaf node, it's not going to be able to use the internal node to set the start and end if they start out as null. So if I come over here, I basically say I want to start at null, and I want to go all the way up to Noreen as my key. And it looks like it brought me all of the A's, B's, C's, and so on. So if I come down here and I can see the Noreen, notice that it only returned 2 of the records, and that was because of this 40. If I did 100 here, I am pretty sure that it's going to be able to find all 3 of them at the very end. Yeah, because the third Noreen, why is this returning 4? Oh wait, that's spelled differently. So the 3 that are spelled this way, I can see that 93 is at the top, And that's essentially what I did. So in that particular case, I can see that our search range, because of the fact that we created a null start, it passed all of the ones before it up to, and because I passed inclusive end, it returned the very last one as well. And I'm just printing those out. So if I were to create a key with Noreen, age 0, and rerun this, it should just return the 3 records. And there we go. We have the other 3 records. So the searches actually work pretty well with the combo keys here. So if I do 13, so it'll exclude that first one, it's able to find 46 and 93. So that's pretty cool. So then we would at least be able to utilize our BTree to limit the other search. And because this is worst and best case scenario, big O log of n, this is actually rather quick to look these up. And I don't have to go through 1,000 records just to come up with this. I only have to come up with a couple of records because it's using our comparator for determining less than and greater than for the other keys. So let's see. So I probably want to basically create a search range based upon some criteria. If we come back over here, we have this search selector. Just ignore the search part. Let's just look at the other selector part. Let's bring over here. Comment this out. Let's say that we have this selector, and this is of type person, which is this local person. First name, Justin. I'm going to change this to Noreen, greater than 13. Let's do 15, just to avoid the 12-year-old. Because this should allow us to at least figure that one out. So now it's just a matter of creating keys that would work with these. I am not entirely sure how to do that, but we can probably experiment with some stuff and figure out what works, what doesn't, and go from there. So the selector right now is just holding on to all of the operators, as we can see. I can collapse that, give us a little bit more screen real estate. And the operators, they have data in them. So what if I, let's create a new class. Let's call it search range. I don't know what to call it. And for this one, it's going to be of some type. We essentially want to be able to, oops, not that. We essentially want to be able to return public some key. I probably use this one for now, but I'll probably be switching this key to a different one once we figure out how this is going to work. Get start, then get end. So what if we were able to pass a selector in? And I don't know if we should do this in the constructor, but it's fine. So we can figure out the start and end based upon the selector. Return start, return end. Then in here, that start equals new key. And a key requires some values and a document ID. I'll probably change that up at some point, but I know I keep saying that, but it's true. All right, so what do we have in regards to selector? And that's going to be the hard part. How do we create a start, basically a search range, start and end, based upon the other data in the other selector? Because of the fact that we're only doing the ascending and descending and we're not doing textual search, that might be a little bit easier. I haven't figured out how we're going to do the textual search just yet, but I probably want to be able to grab the operators. This is in the same package, right? I can just make that one package private. Operators. We basically need to create some keys based upon this, right? We can ignore the field name, because the whenever we do the selector, the field names in the operators here. This isn't even an operator, but the field names here, they're specifically used to figure out which index to use. So I'm assuming that we're using the appropriate index, so I don't even need to worry about the other field names, because we're not going to be extracting that as part of our search. We're basically wanting to create keys that represent these values. So basically going through all of the values and figuring out a start and end for each one of the operations. And by default, if you remember, the default is an equal. So this is no different than me doing this. And I think by default, it actually does wrap it in the equals. So if I get rid of that, go back here. Yeah, here it's just adding the equals operator and delegating to the other method. All right, so for each one of those operators, probably want a for each, and we kind of need the starting and ending values. So let's create a list of some object, and these are going to be the start values. In values. And for this, we have the other start values, just a dummy document ID. I don't know if we need that or not. And then we have the end values, and those are the other two keys. So now we just need to figure out for each one of these operators, what would be the start and end value of each one. And these do have to be parallel. So I need to make sure that whenever I add one to the start values, I add another one to the end values, even if it's null. Well, let's just grab the operator. Oh, that's an entry. Get value. And now it's really, we just have to figure out what the instance of each one of these are. I'm just going to do the naive approach first. And let's just go ahead and do, oops, this as just if else statements. So if the operator is of equals, we grab the value of it and we can probably just add that to both the start and the end values, right? See, that seems logical to me, because if we pass in Noreen in this particular case and we're expecting it to be equal, it means that we need a key that has exactly this as the first part for both the start and the end of our search range. So search range person. Let's just go ahead and throw that in there. Actually, just in case we need that selector for something else, I'm going to pull it out as a variable selector. And then BTree search range, range.get start, range.get end. I want this to be inclusive. I want to map to grab the other keys from these because I don't care about the values right now. And I'm going to system.out println each one of those keys because I basically just want to see if it's creating it appropriately. So this should technically work, right? If I were to run this, it'll return all three Noreens. No. This is that index out of bounds that I was mentioning. I do need to solve that one. Eventually, once I replace this key, it's not going to be a problem anymore. But for now, let's just go ahead and fix this where I can probably do if other key values size is greater than I, other key values get at I, otherwise null. So if the other key value size is greater than I, I'm able to get that value. Otherwise, I just return null. And then it's able to do the compare to null. Here I have the B is null. So here I'm just assuming that it's greater than. That's why we probably need to rewrite this key. That way we can get the enter field direction, because right now I'm just creating an index with ascending age, ascending first name, but not doing any kind of descending work. And that's exactly what this is doing. So this is going through all of the key values and comparing them with the other key that's coming in. I don't know if we need to do anything special. Yeah, let's figure that out whenever we get there. But let me go ahead and rerun that. And we shouldn't get that index out of bounds exception at least. There we go. That did not return any that time. And let's figure out why. So in that particular case, we're trying to search for Noreen. Let me just put a breakpoint here. And let's go ahead and run this in debug mode. That way we can actually see what... No, that didn't work. Oh, I am pausing all my breakpoints. All right, here we go. Let's go ahead and disable those. Here we go. So my range start is Noreen and Noreen as the starting and ending. I'm ignoring the age for now, and that should be fine. Because if we take a look at the BTree, let's take a look at the root. Let me just look at one of the keys, and we can see that the key values is Emily and 80. So if we are looking at this, can't remember which direction we are comparing. So let's go ahead and hit play and get to here. So this one is the one from the BTree, and the other that we're comparing with is the one that we passed in. So I would like to see what would happen if those were equal. These are all comparable. If B is null, which it won't be on the first value, but it will on the second time that we go around. On the first, it'll probably just come up with that value. And it's going to be -1. So then it goes around the second loop, because the key in the B store has two key values that it's comparing against, and that one it's going to be comparing 80 with null. Here, I can probably just do that. So let me go into that first one. We can see that A and B is Emily and Noreen, and then the second time we come in here, we have Lynette and Lorraine. Oh, it's because we get down here, the value is not equal to 0. So we just return that. So we short circuit it so we don't have to go through all of the key values. So here I should probably, well, this shouldn't be long for us to find this. So if here we go. So it's like 4 clicks in, and that's the big O login. We were able to find a Noreen rather quickly in our BTree. All right, so here they're going to be 1. So next time I go, we can see that we're comparing 46, which is the one that's in the other BTree, with null. So if that's null, then we assume that this one is greater than that one. See, and that's where it's problematic. We might have to do something specific about nulls. So what would we do with a null? Because here B is null and we're just passing 1 by default, which means that this one would be greater than this one. Because a non-null is greater than a null. Right. See, and that's, well, let's take a look at that. So if both sides are null, so if A is null, then it's not going to be an instance of comparable. And that just does value, else if B is an instance of comparable, then it returns -1, which means that A being null is less than B, which is non-null. and it returns -1. Of course, I don't have anything. I guess it's 0 if both of them are null. Yeah. So if A is null, it's not going to be comparable, and if B is null, it's also not going to be comparable. So the value is 0. So then it just returns the 0, or goes on to the next node. So that's correct. Right, and that one I am not entirely sure. Because I can do something here. Let's do something really weird and do a lesson learned from it. So for this one, we have the equals. The next one that I do in my test is a greater than. So else if operator instance of greater than. So then if I see, and this is the weird part, because the way I would do this in the naive approach would be if we're looking for something that's greater than the start value, we're going to add the value. And the end values, we're going to add integer max value. So we're going from this value. I mean, of course, this is greater than or equal to. So I'm not entirely sure how to do that one. I mean, this would at least doesn't mean that the search isn't able to further filter. This is just going to at least limit the number of records that are coming back. So we might have to rely upon that. I am not sure. You can't do that, can you? No, I didn't think so. Yeah, I don't know how to fix that little that warning message. All right, so then if I were to run this now, and let's go ahead and pause all of our breakpoints. This time it returns these two, and that is exactly what I was expecting it to do. I don't know if I like that approach, because here I'm expecting it to be an integer, but we could do a greater than with a string too. So it might get into some weird behaviors if I do it that way. Might have to play around with some ideas for some max value kind of stuff. So what if I had, let's see, let's rewrite the key probably. I'm going to start with this class, but only because I'm using that key class right now and I'm not ready to replace that yet. So I'm just going to call it key 2, electric boogaloo. And get rid of that. And key 2. I'm just going to grab this stuff. And do that. Key 2. I don't care about the document ID. I might have a flag that represents max value, because if I see the value is a max value, then I don't have to worry about the data type. That might actually be kind of key, right? Yeah, let's do that. Which also means that my test here, I'm gonna have to create the keys with key 2 instead of the other key. Yeah, that's fine. This is going to be key 2. And this is going to be comparable to key 2. Don't need that dummy doc ID anymore. Right? Oh, it's because it's returning the wrong type. Key. Let's just get rid of that. Just go through here and replace all of the uses of key. I know. I probably could have done this in a quicker way. All right, that looks good. Over here on my search range, I can change these to key 2s. Don't know if this was easier or worse. Thinking worse. Don't need that. I don't know why I had a document ID in there to begin with. Maybe it was just to make sure that the key was correct. All right. So now that we have that, I can probably, I'm going to leave this line here because that does fix that particular problem, but I don't need that open anymore. I can close that, I can close that, and I can close that. All right, so let's take a look at the key 2 and modify its behavior a little bit. So we assume this will always be from perspective of the keys in the BTree, because the problem is if we were to create a key that has more values or less values, that's going to give us some problems with comparing the other two keys, right? Slack keeps going off, but I'm not entirely sure why. So then I can probably do private static final. I don't know what to use for this. Maybe just a char max value. No, I can't do that. I need some sort of indicator that it's a max value. I should probably, yeah, I can just do object and then new object, private or public static, public static. All right. So then instead of an integer max value, I can just do a key2 max value. And that should be enough for us to identify that it's a the max value versus min value. So then I could do the same thing with if operator instance of less than. Do I have that one? No, I do not have that one yet. I'll do that one later. So this should work on strings too. So now we have to figure out how to do the comparison here. Not entirely sure how to do the greater than. Because this is basically a greater than or equal to, the way I have it written right now. So we'll have to figure that one out. I'm just gonna get a lot of emails. So what should we do if the key values are not the same length? Because we're also assuming that we shouldn't have a problem with that if you think about it. Because going back to what I was saying before, whenever we have a query planner, it's going to have to determine which index to actually use. So then it'll actually create the keys that are specific to that index. So the values should always align up. So I might not have to worry about that. I could be wrong, but we're making a lot of assumptions here. So that shouldn't ever happen. I'm just going to do it that way. Could potentially cause index out of bounds exception. I don't know if that's the right abbreviation. So if they're B's comparable and B is null, it's going to return 1, which means that nulls are less than basically nulls first. Otherwise it calls compare. The one in this shouldn't ever have these min and max values. This is solely intended for search ranges. So I guess here, if B is equal to max value, else if B equals min value, else val equals, so that's the max value, so that would be a -1. This would be a +1. Otherwise we actually do the comparison. And this will only be called if A is not comparable. Yeah, I mean, that could possibly work. Let's go ahead and rerun that and see what it does. There we go. So if that's the other case, I should be able to do... where is that? In my test. What if I did Noreen, like greater than Noreen? Of course, this is going to be greater than or equal to because I haven't figured out that other part yet. But this should return everybody after that. So Noreen at age 15 and up is going to be returned. Yeah, that's not too bad. Not too shabby. I mean, the complex stuff could come in if we want to do a range of first names. If we want the range of Noreen to Olga, we would have to have an and inside of the first name, right? Oops. And I'm not entirely sure how to do that. Not at the top of my head. So this is probably going to be like a recursive call. I'm not sure exactly how to do that. The interesting thing is we could, for our in values, we don't necessarily have to do stuff like this. We can do the start and end values and then throw on a custom comparable. They don't even have to be the same type. They just have to be some implementation of comparable, because then whenever we get in here and we call A compared to B, as long as the other one is comparable, no, because the one from A is being called. Ugh. Would have been nice to do the B compared to A. I mean, I could still probably do that and just reverse the sign. Just always multiply it by -1. That way we can have the B side, which is the search range, the start and end, actually make the determination itself. Let's put that in the bank. We could probably utilize that because these are hand in hand. The index and the key are basically working together to limit the ones that we need. Okay. All right. What other operators do I have? I guess I only have the equals and greater than. I can probably create a few more. What are the operators in MongoDB? Because before I was looking at PouchDB and it has its own language, like Mango or something like that, to do its searches. Nope, that's not entirely what I wanted. I wanted the documentation. It's a presentation. Products blog. Where was I finding this before? Let's see if I can find. Yeah, here's the some documentation. These are the compound indexes that I was looking at. And we have the 2D sphere indexes, 2D indexes, geo haystack hash indexes. So that's why I'm thinking that the index thing needs to be a builder, and it can determine which one of these implementations of index it would actually create. There's an in query operators. Here we go. So I have equal, greater than, or equal, in, less than, equal, not equal, and not in. Those are for the comparison, but then you also have all of the logical operators, which can those can hold other operators. Okay. All right, so let's greater than. I should probably do this one as greater than or equal. Yeah, let's just go ahead and create these. What do these have? It looks like it's just passing up a value operator. So these are more like comparisons. I could probably create most of these in between. In is kind of interesting. I have no idea the start and end range for in, because that's basically going to be passing in a collection of values, and it can be any of those, which probably would have to look at the BTree multiple times for each one of these values. I mean, it's going to be big O of n, log of n, basically, or column equals value 2. Right, I'm just trying to think of how the operators can filter to identify which records to actually look at. So I guess that's a good point. So let's come over here. We have the that guy. First name is Derry. So let's do or in. Let's just do in. First name in. How do I do that? Is that how do you do that? No, that's not how you do that. How do you do that? Looks like it's an object, and this is the key to an array. Yeah, there we go. And Noreen. All right, so that time it gave us this dude named Derry and Noreen. I suspect you can get clever by sorting the list of values and use that to avoid traversing the whole BTree, since you know the next value is always greater. True. Yeah, like I said before, yeah, that's a good point, because I can go through the in, sort it, grab the first one and the end one, and that's going to be part of the start and end of the key. And of course, we're just going to have to further filter once we get the value, or once we get that search range and we get a subset. Then we definitely have to query less. And that's why I went over here, because I kind of want to see this one. See here, we had to examine 1,000 documents because we did first name and using in. So this is actually scanning all of them. I think we can do this a little bit faster than MongoDB, actually. Let me just redefine this just to make sure that I'm doing this correctly and I'm making the correct assumption here. But I want the first name, and this is going to be ascending. Come on. And age ascending. Basically, just going to create it identical to what we're planning in our side. Do that find. That's cool. Do that explanation. All right, this time it did do a fetch. So it did look at 6 keys. And it returned 4 documents, but it looked through six keys. This one may have done individual searches. Yeah, I guess it depends on how many records in between there are. Because if I did like Zeta or some Z name over here, and it would have to, if it were actually going across that linked list and grabbing all of the records and doing further filtering, it could actually get like 1 million records in there, and it would be a little bit faster to basically just do multiple searches and doing a union of those results. So in might be a little different. Which does throw a wrench in a lot of this stuff. Because an in is basically multiple queries with equals, the equal modifier of each one of these. Not modifier, operator. So Zaza at the very end. Yeah, if I were to do in with Noreen and Zaza, it would have to return this many records on that initial go around and then have to further query, which, yeah, it's possible that worst case scenario is going to look at every single record in the other database, because if I were to do an in operator with Albuquerque and Zaza, whoever's first in the list, Aardvark, it would have to search all 1 million records, or how many records are in this collection, do the further filtering, and that's not good. So I think it would be better to do a union. Same thing with OR. OR is basically the same sort of thing. Doing a multiple searches and doing the union of them based upon the other field. Because if you look at the filter here, we have the field name as the key. And then it just determines how many queries that it has to do based upon the operations inside of that. And it's assuming that everything outside of it is an and. I don't think I can do an or on the outside, can I? Can I have an or here? Then do a first name. This one won't match an index. So if I do age, greater than 15. So this is an or, first name in this, or the age is greater than 15. I really doubt that's going to use the index. Oh, must be an array. Really? Okay. I'm just not knowing how the query language works on this. So that's in. Let's look for or expression 1, expression 2. Oh, really? That does look like it's going to have to do multiples. So or has to be an array of these things. Which the first one is going to be that. And the second one has to be that. Oops. Didn't mean to do that. That one right? Yeah, that one's right. All right, so then I did have to examine 1,000 documents. Probably because the age isn't, because it's doing multiple queries, and the union, it had to look at the age separately because there's no index for it. If I were to create an age index, I am assuming that it would use that for that second part of the fetch. Yeah, here. So that's what basically what it does. So it creates a sub plan where it's going to fetch, and then it's going to do an OR, which is 2 different index scans, one with the first name for this, and then the second scan is going to be for that because that one matches the other part of the OR. Which does mean that the index scanning is going to be very interesting because we can't exactly, well, I mean, we can ask the index how to scan the whole, what did I call it? Selector. Probably not. I would probably want to break the selector up and just pass the index the part that it actually needs to care about, because otherwise it won't know to split these off. I'm just trying to think of who owns stuff, like the responsibilities for breaking some of these things apart. This one, it kind of looks like the operator. I mean, basically on the visual tree, if we take a look at the raw one, we have the command, we have this filter, it's an array for the OR, and then we have the 2 sides here. We have greater than 15, and in is an array of Derry and Noreen. Yeah, because we should be able to at least do like a pagination with this as well, being able to skip, limit, all of that sort of thing. And that's what I'm trying to do over here with the find. We have the search, which the selector part, I guess that matches up most with the filter. And then we can tell it which index to use. We can, I haven't implemented it yet, but we should be able to also pass in like the skip and the limit and all of that stuff as part of the search object. So the command here relates to the search, selector is the filter. Yeah. Yeah, we're going to have to figure that one out. Getting into some of these more complex queries here, we're going to start hitting our wall. Let's go back over here. So we have greater than Noreen, greater than 15. Of course, this doesn't do... this isn't doing, all this is doing is grabbing a search range that would be viable to include everything that this selector would have. we would just have to further filter based upon the actual content of the selector once we figure out the other range. Honestly, it probably means that we're going to have multiple ranges. So if we were to create an in operator, so how do we do the in operator? This is going to have to be multiples. Basically multiple equals. And I could probably do it in here. Values, and this can't be a value operator. So what does the other value operator give me? It just gives me a value. I guess in that particular case, instead of equals and greater than, well, I still have to do the other greater than. Yeah, I still have to do this, unfortunately. I could just break it up into multiple groups. But the in can't be a value operator because it's not operating on a single value. It's operating on multiple values. Yeah, I don't know how that's going to work. That one is kind of complex. Yeah, I just basically need to be able to figure out the other search range or collection of ranges. But whenever you're starting to nest some of these, it gets a little bit more complicated. Can you nest? Yeah, take a look at the in. Does it have to be value or can it be expression? So values only. But it looks like you can also do in for aggregation. Yeah, it's a little bit more complicated. I don't know how much I would want to do on this, though. Seems kind of silly to have a full implementation here whenever really I'm only expecting a fine-grained set of operations. Heck, I can even make it where you can return, like basically nest your own custom operation, and it'll be able to add values for the other start and end. Yeah, I'm gonna have to write that down and just circle back to it. I am not entirely sure how to proceed with that one. I'm going to ignore it for now. Of course, I need to implements operator. That one's not like that. Static t in of t in t values. Yeah, don't know if we will want to do anything with that. Heat pollution. I don't know. So let's keep with the simple first. I don't know if I should be doing this in the index or should I be doing it elsewhere, but let's go ahead and create an index. I'm probably going to take a look at our previous implementation just to have something similar. So we're going to query the index for this stuff. So our index 2, I can probably copy and paste some of this stuff. And this is going to be the BTree. And I don't know if I wanted... yeah, it's going to be key 2 of D. And this is our data type. And because the values could potentially be... See, and I guess that's one thing that we have to figure out, because I could create a subclass specifically for unique indexes. In that particular case, we would just expect it to throw an exception if we try to add a key of the same type. Otherwise, it would probably need to hold on to a list of the objects that we're holding on to. Kind of want to be a little bit more specific over here. So what am I using the JS object for over here? Basically to be able to create the trees and inspect the object, right? I'm trying to make this in a generic way so that I don't have to rely upon a JS object. I don't think I can create a JS object in the JVM, right? Yeah, maybe I can. No, I can't, because most of these are native methods. Well, that would not work. Are there subclasses of JS object specifically for tests? Doesn't look like it. Yeah, I guess in this particular case, I kind of need a builder, right? What do I have in regards to code on the Mongo side? Looking for my browser. Here we go. Probably doesn't have anything. How do I create an index? I'm assuming that there's going to be some sort of, yeah, here we go, some sort of JavaScript. So here you can pass a separate object for extra options. And I think that was what we were seeing over here whenever we were creating the index. All of these additional options would be sent as a second index or second config object. Single field indexes. So how does it know when it's a unique? Oh, here's the index intersection. This is how it might be able to use index intersections, basically being able to execute against multiple indexes and taking the intersection of the results on both, and that is basically the and between the two. That's actually kind of cool. But I'm kind of curious, how does it do the unique? Yeah, it creates a unique index on the ID field, and we did see that over here. We did see it creating an index specifically on the ID field. Can you specify? All right, unique property. Okay, there it is. So it does look like it's in the second object. Determining if it's unique. I can probably do this all in a single builder. Yeah, let me do that. Index builder of whatever type. I can do D for data. So what if we had index 2 create? That is basically just going to return an index builder. Probably change this to build instead of create. Index build. Maybe not build, but builder. I want to be consistent with something here. And then probably create at the very end. And that would create an index 2 of person. Oh, it's because the constructor is private. That's fine. I can make that package private. Not sure how I'm going to do that yet. right. So this is basically where we can do a field first name and type. Probably don't want it there. Let's put it in the index. Descending text. I'm not gonna do any the 2D sphere stuff. Really the only types that I have. And I could probably do an overloaded that assumes ascending by default. All right. Here we go. I'm gonna turn up the music a little bit because I'm gonna try to concentrate on this a little bit. Yeah, I couldn't either, to be honest. No, I enjoy the music. I can hear it in my headphones. I think it goes out on the stream a little bit quieter than in my headphones. That way, if it's too loud for me, I know that it's definitely too loud for the other stream. All right, I'm using a linked hash map there, just so that it retains the order of these keys. Index name equals index name. Create that field. I don't know if I need any other options right now. Probably need the unique. Um, So this is basically going to allow me to specify if it's a unique index or not. So down here, whenever we create it, then we can decide if it's unique or not. We can basically return the implementation based upon this criteria. So I might be able to separate this into a different class. This can be like a abstract class. Then I can have subclasses of this. So let's create a unique index. This will be fairly simple. I could probably actually need to create a let me do a base index. That's different than the top index as the API. Index 2. Most of these are probably going to be package private. I don't know, might change that later. That way I don't have to confuse the implementations here. So let's put the base index there, the unique index here. And I'll probably be pulling out the BTree stuff separately. Builder degrees, that's fine to be here. Actually, implementation details I should probably just put in here. This will just be the API and the entry to the builder itself. Here, we're actually going to do BTree type is going to be different than the data. And it's not really a data. This is going to, yeah, it might be. I don't know. We're going to have to figure that one out too. Where's my key? Key 2. Do I use that D for anything? Doesn't look like I do. So I don't think the key actually needs to be parameterized. I might change that to remove the parameterization. Let me where's the original index? Do I do anything with the D? Besides the key, doesn't really look like I do. These are all private. I'm assuming it's going to have to return that data type at some point. Because it's going to be the index based upon that. So yeah, I think I still need to do the model type. Let's see. So the unique index here, I am going to say this is going to be trying to think of how this is going to work. Basically, I want to create in the base index a private BTree of a key 2. And again, I don't think this has to be parameterized. Let me remove the parameterization, just use the raw type here, and let's see what that does. And this is going to be the type. Let me do V for value, because this is going to be the value of the BTree. Yeah, because the value is the actual value of the bean that we're holding. Protected. I'll just do this for now. I can change that up later. So a unique index, we're just going to be holding on to the value directly. I don't think I need that first. But we'll see. Let's see what kind of methods that we need. Don't need that anymore. Don't need that. Related problem. This one right here. So if unique, else, composite index, I don't know. This is going to be D, and a list of D. This is basically that second parameterization is what the BTree is going to hold as the other values, because this is a non-unique index. We need a collection to hold overflow for any particular key. So if we have multiples of a single key, we need to have a list that holds those. I need to figure out how to do removals and stuff like that from the index. So return new composite index. Otherwise, return new unique index. Oh, new. I know I don't need a else there. Might have to have an else for something else later. All right, so for the unique index, this one's going to be important. If we don't have a unique index on this base data that we have, it's going to have a problem. So first thing that I'm going to do, let's attempt to create a unique index on first name, and let's make sure that it fails. because it can't be unique. All of this stuff, it doesn't really matter which order. All right. So if index name equals optional of nullable index name or else get supplier. Here we're probably going to want to create something similar to what this does, actually. Might be fun. Right, so then for each entry, how does that work? Yeah, I've never used the mute button on this before. Yeah, maybe I'll just do a couple of things. Int value. No, I don't want to do that. Let me just do a string. E. Let's just do these as strings. You can always refactor later. And then bind that. Oops. Bind that to a field. And then get key. Yes, I know. I do a lot of dumb stuff whenever I'm just starting this out. All right, so for each field, we want the key name.append key, and then append entry.get value key. Right? Then I guess we're wanting to join all of those with underscores. Let's map these. And instead of that, I can just do entry get key plus joining it with an underscore. Yeah. Entry get value, get key. Then for all of this, joining with an underscore delimiter. Oh wait, not that. Yeah, turn that. Don't need the string builder anymore. Get rid of that as a lambda. Do the same thing with that. That would go here. There we go. So that will basically create the same sort of thing. So if I let me suss out the index name. Let's just run that as is. Should probably skip the rest of that stuff. So first name 1. So then if I were to do field age type descending, should be first name 1, age -1 as the name. I think that's what it does. So if I did a first name ascending, age descending, create that index, yeah, it has a -1 in the index name. All right, so that's only if the index name is null. It just generates that. If it's unique, it just creates a unique index. Otherwise, it's a well, technically a composite could be a unique. So that's kind of silly. Other index. I don't want to call it composite because all of these are composite. Only if you have multiple fields, that is. So here, I guess it's just index name and fields for both of these, right? That's the only thing that we're building right now. All right, so let's go ahead and create that constructor. Cool. Let's create that constructor. Cool. I mean, technically we can go up into the parent class here, and let's go ahead and extract that out into its own constructor. So protected base index. This is going to be string index name, map string type fields, and that does have to be an ordered map. Let's bind those fields. It's going to be final. Cool. And now we can do super on this. Index name, fields. Index name, fields. All right, so now all of that is in the super class. That is spectacular. All right, so then what do we want to do with this index? We probably need to populate the index with values. So the way I did that before, let me actually move that one over here. I had an init method. This right here that returned a promise. So then once it finished, it's basically just made it asynchronous. Should probably just wrap all of this stuff in some promise stuff later. That way I don't have to put the other promises in the index itself. That way I can have index operations being synchronous, single threaded. So So don't I do this again? So whenever I add a value, yeah, I don't have anything that does a re-index. Should probably do a re-index. Because this would basically flush the BTree and allow us to re-index. I don't know if it should flush it or just create a brand new one and just start from scratch. Do I have a clear method? Public. Re-index. Free dot. No, I do not have a clear. Clear would be so easy to do, though. I might as well just do that. Create a clear method in the BTree. Because all it has to do is re-instantiate the other root node and just drop the old root node. That's pretty simple to do. It's reassigning root all the time, anyways, because of splitting. All right, so all of this is builder related. So now I just need a public abstract void re-index, and I am not entirely sure what I'm going to do with that. First things first, let's go ahead and create a method in the B plus tree for clear. This dot root is equal to new leaf node. That's it. Oh wait, I need to pass some junk into that, right? Let me clear. Let me initialize it like this, and then put this in clear. Ow. I guess in that particular case, I would have to hold on to the comparator and the number of degrees. That's fine. So let's bind those to fields and then call clear. That would be fine and dandy. There we go. So whenever we re-index, I can get rid of that. Actually, I should BTree test. This one right here. Let's just there it is. Had no idea where it opened up at. Let me just run that unit test real quick, just to make sure that it's still successful. That I didn't kill anything, and it looks like it's good. Any kind of refactors probably should always run your unit tests on it. So with re-index, I kind of need to be able to grab the data. So looking at the old index implementation on the init, basically grabbing the GWT raw access, and it's able to grab all of the JS objects, iterate over those, and for each one of those, it's calling add on the tree, or on the index tree. And we probably need to do this a little bit differently. However, I've been going for 2 hours now, and I need to take a small break, feed my cats, switch out the laundry, things like that. I will be right back. All right, I'm a little bit early, but that's fine. It's only 42 seconds left on the clock. All right, so basically I'm just trying to figure out how to re-index with whatever data that's been given it. The re-index, obviously we need to clear the tree, but then we need to be able to go through some sort of collection and add all of the items from the other collection. Oh, thanks for the other follow, ZooGod 5000. Thanks for joining us today. So yeah, I'm just not entirely. Oh, thank you. Yeah, there's not a lot of Java streamers on Twitch. They tend to stick with Rust or JavaScript or things like that. So I kind of want to make this in a generic way where I don't want to necessarily grab JavaScript objects. Yeah, I know. I'm not a big fan of React. But yeah, I have noticed that most development is React or game development. Game development's fine, but for this kind of stuff, I'm not a big fan of React, and that's why we're looking at Gwt and Jackal for our web development using Java. Right now I'm implementing some in-browser database stuff using Gwt and Java. Got the BTree working. Right now I'm just looking at creating some indexes to essentially find data for me. So if I were to do a unique index, this one should actually this one should fail, but I need to be able to re-index with some sort of data on it. And I am not entirely sure. What if I did a person list dot saying this is assuming, because I already created the BTree up here, but I'm wanting to get away from that because I want to use the BTree that's actually in the index. JS Python. Yeah, I haven't really done much with Python. I was a Perl guy back in the day. I know enough Python to troubleshoot and stuff like that, but not a lot of work experience with it. So what if I were to pass like a stream of D? Oops. Import class. Technical interviews. Do they ask a lot of Python in interviews these days? It's been a couple of years since I've been on interviews. And whenever I was on interviews, it was all Java related. So I need to be able to create a key from that object. Oh, right. Yeah, I tend to, I know that it's a little bit more wordy to do Java, but I tend to stick with Java for any kind of algorithm stuff. don't know what the best way, because I kind of don't want the index to know how to pull data out. So it's like I would need some sort of key creator. Because whenever it passes the object in, it needs to be able to create the key. And it has to create the key based upon the information in the index. So it's kind of a catch-22 here. I might just overload it for testing purposes. Okay, yeah, no problem. I try to have a Bob Ross type stream, just calmly talking into the mic, nothing extreme with loud sounds. So could be good background noise, I don't know. Person list. See, yeah, I'm not entirely sure how to do the re-indexing, because I not only need the data, could either be a collection or a stream, it doesn't really matter. And I need to be able to have a key creator. How do I generate the key? Because for each data point, I'm going to need to extract the values from the provided bean that's coming in. Yeah, I might do that. Let me create a new class. Value provider. I don't know if this needs to... I know that in GXT it had like value providers as well. Those were auto-generated. I'm trying to do this without having to auto-generate stuff, but I need to have a differentiation between the JSON object, which will just use the strings, like first name and age, for their properties, because it's going to be a property map, versus JVM that's going to essentially use reflection for getting that stuff. I kind of want to have the best of both worlds. Because looking at the old way of creating the index, we're basically yeah, and I guess that's the other thing. Whenever we're re-indexing, the unique index is going to have to do it slightly different than the other index, whatever that's going to be named. Because over here it's going to check to see if the value is already in the tree, and if it is, it has to basically, it knows that it's a list. So if I look at my tree here, my tree is a get. Yeah, it returns a list. So if I give it a key, it's going to return a list. And I should be able to, if it's null, obviously, I would have to create a new one for it. Instead of a value provider, I wonder if I should do a value extractor. I should probably do a path. Because if I have a path, then I would be able to index fields such as address.street. And it would be able to basically index that value from the other path. Yeah, and I guess I can create a yeah, I don't know. So with my other one, I was just assuming a JS object. Which this is a little bit different because in this particular case, we're creating an index of person, but it's also holding JS objects that represent a person, but not necessarily the other person itself. I don't think I really needed that parameterization there though, because I'm not actually using it in the key. And I also need a key generator, and that's the other thing that I'm going to need. Basically being able to pass a object to it and I'd construct a key from it. And the other key has to be matching the fields that we passed it originally. Let me clean up some of this cruft that I have here. I can keep that. I can probably throw that away, Get rid of some of these classes that I'm not using right now. Value operator and key 2. All right, how am I going to do this? Just need to be able to re-index. I mean, I suppose that might actually be kind of cool. So for my my database, if I had a, I don't have it right here, but my main entry point, whenever I'm creating the index, create index, I'm changing it so that I'm using a builder now. What if I were to pass the builder to the other create index, and then the create index is able to modify that builder before calling create? That actually might be beneficial, because then I can put some extra stuff in here, such as value extractor. New, and I can create a value extractor that's specific for the other JVM. Reflection data extractor. Value. Let's just implement it that way, and we can see if that's going to help us or hurt us later. That's fine. So public index builder of D, value extractor, some instance of value extractor. let's go ahead and create a field for that. All right, so then I can create a reflection value extractor. See, and this is where I need to figure out, am I going to have a singleton? Well, singleton. Am I going to use the same instance for the life of this index, or should I be passing it like a supplier that's going to be able to create a new extract? It doesn't make sense to create a new extractor for every single bean instance, right? I should probably get the value of the bean with the appropriate path. Come on, did you import it? There we go. Obviously I don't want that, but if I were to do that, this would be possible then. So I'm just going to do one in terms of reflection, and this one's going to be GWT incompatible. I'm not entirely sure which one. Maybe that one. And the other one I'm going to have is going to be JS interop value extractor. This one is basically going to grab the bean as a JavaScript object, and then be able to do like a JS as property map of that bean. And then from that property map, we can recurse down the string path for that. Yeah, that's fine. So then if we re-index, let's just pass it the list for now. And we'll probably change that to a collection. Ooh. That is not what I wanted. Collection of D. Yeah. All right, then down here, list or collection of data. And that overrides. There we go. All right. Let's concentrate on the other reflection side first. I don't think the the JS interop value extractor is going to be that difficult. But this will at least pull that interface out so that we can plug in the implementations last minute instead of relying upon the implementations. So path, if path equals null or bean equals null, return null. And we want to split on period, just in case it's a multi-part. Oh man, I probably want this as an array. Yeah, arrays of, or as list. There's my path list. Private v value, or get from path. Yeah, I could probably can't be a D though. I would have to do it on some sort of object. And rename that later. All right. So here we're going to have to recursively, or probably can do it probably with a for loop. And here, object current equals O. If current equals null, return null. All right, get class. Wonder if I should just do the bean introspection stuff to grab the properties. Bean descriptor. I cannot remember how that works. Yeah, how does that work? Let's Google this real quick. I just want to do the fast way instead of doing all the stupid reflection. And I don't want to import any kind of libraries for like a reflection utils. Java being descriptor. And we get the value. Ugh. That's not even there we go. Introspector. We can do that, right? So this is doing an introspector on that bean class. It gets the bean info, property descriptors. Yeah, let's try that. So introspector, get bean info on current class. Yep. So in that particular case, if there's any kind of introspection issues, we need to return null. Yeah. That's not the right place. I was looking at the old stuff. Get property descriptors. Oh, this is having to go through all of them that way. Oh, this gotta be a faster way to do this. Could just add Groovy to my dependencies and just do duck typing. It's one of those things that I don't use too often. So I end up having to look it up. That's just an array. I can do that. It's not going to be the most elegant solution. Yeah, I like the other way better. What does that do? Attribute name. Retrieve the named attribute with this feature. What? Oh, not the descriptor. I wanted the yeah, descriptor. We need to throw that in a debugger. I am not entirely sure. Get write method. Because I need the actual value. Get read method. Guess invoke that. on the O. And that returns an object. Go ahead. Let's just change that to exception. I don't care. Or wait, yeah, I do. Ooh. Get property value. I should probably just return null if any exceptions happen instead of letting those bubble up. So current and field. Yeah, let me do that. I guess if it didn't find it, I should also return null. And we can remove that throws. There we go. All right, so now if I get the other property value, this is basically just going to be current, right? Current is equal to that. If current is null, turn null. And we don't need that try catch anymore. All right, so we get from path, we go through all of the dotted values. Oh, I guess that's not nullable. Ha ha ha. Just path split. I don't know why I did the of nullable before. So we grab from the other path. I mean, technically, since we're not, we don't necessarily have to separate that out, but this is grabbing the current object and the other path as a list, and for each one of those, we grab the property value at that current place. We need to return current, not null, right? And hopefully we don't get a class cast exception. If we get to the end of that path and we get there, that's buyer's remorse, I guess. If you try to extract a value of a certain type at the very end of that. No, that's not right. That is absolutely not right, is it? No, yeah, that's right. Because I could just use the other raw type, and that would be fine. So if I did, let me test this out real quick. If true, return. So let me open up my debugger and run that. Let's just make sure that it doesn't really do anything. Cool. And let's create a new reflection extractor. And then we want to get a value from a bean. And we're going to say first name. So person bean equals new person. Justin Hickman, and I am 20. I am not 20. Oh, wait, I need to system out that. Otherwise, we're not going to actually see the other result. And that is not correct. Oops. There we go. So if we run that, it'll print null. That is not right. First name. This does have all the getters and setters, right? First name, first name. Yep. Well, let's figure out what is going on from the get-go. Get path. Let's go ahead and do this. Let's go ahead and run that with our breakpoints on. We have a path list. We have first name. And we come in here. Let's go ahead and grab our property descriptors of O. Let's take a look at these. Introspector dot get bean info. O dot get class. There is our bean descriptor. And then we want the property descriptors. And we have 4 property descriptors. We have age, class, first name, and last name. And we are looking for first name. Yeah, so this should work, right? Yeah, here we go. We found the other first name, and let's go ahead and step out. And current is null. Why is current null? Evaluate expression. Let's try this manually. So what is O? O is right. And we are getting 0, 1, 2. Are these all seems to be consistent enough. So get read method, invoke on O, illegal access exception. They're all public. Not access member of with modifiers public. Oh, is it because my person itself is private? That's probably what it is. So can I change that so I can call it? I'm gonna make that public. I can't recall. Remember, we have to set the method as basically public in our reflection. Yeah, that's a little bit different. Here we go. Set accessible. Oh. Set accessible. True. Stop that. Kill it. Rerun it. Let's see if we actually get it that time. Yeah, there we go. Just had to set it accessible. Right now we don't have any additional objects in here, but I'm wanting to see real quick if I have a class address and string street getter and setter, constructor, and constructor with street in there. There we go. And then down here, let's private address. And let's go ahead and getter and setter for the address. Here we go. And in our test, obviously our test mock data is not going to have the address, but I want to actually create here. So bean set address, new address, that Boo Street. All right. So then if I were to do address street, that should return Foo Street. Yep, there it is. And if it were null, shouldn't fail, should actually return null for any null path. And this is sort of like the other groovy way of doing, like being, how does that work? Being, is it dot question mark? Who? Something like that, where you can put a question mark on the dot, and it'll basically just it for any chain method that is null, it'll just return null for the whole thing. All right, so there we go. That works to being able to extract out properties in the JVM. Obviously, it's going to be a little bit different in the other JavaScript side, because those are just going to be like JSON, just JavaScript objects with properties in the clear text. So we should be able to do those pretty easily. Let's go ahead and get rid of that stuff. Now that we have this reflection value extractor, should be able to implement that. To do implement. I will implement that later, maybe off stream, because that's already 3 hours into stream. Let's see. So now if we want to re-index, now we can re-index with this data. Record. So I guess in my index builder, I'll probably need to pass it the value extractor. And let's go ahead and create a constructor for that. Nope. I want to modify. So let's go ahead and value extractor of D, I guess. Do I actually use the type there? I don't know. Nope. I'll just do it here too. Value extractor, D value extractor, and then value extractor. I'm not a big fan of doing constructors like that. I'll probably change that up later. But I just want to get to the meat of the issue instead of dealing with all of the boilerplate stuff. All right, so now that we have a value extractor, we can value extractor this stuff. All right, so then for each record, we have the fields. So if we were to create a new key 2, that just has a list of all of the key values. And the key values is basically going to change for every single record. Hello. All right. Well, list of object. This is going to be the key values. Array list. So then for each entry, I wonder if I should just pass in the fields into my key. That probably is not a bad idea because it also has the directionality of every single field, because we kind of lose it in here if we just have the key values. I mean, we need both. Well, let's just create it as is for now, and let's just see what we get for each entry. This is going to have the key values. So for each entry, we're going to want to grab the value extractor, get the value on the entry. No. What am I doing? I need the bean, and this is just the field. So this is going to be the record, and entry.get value. No, get key. And that's going to be the field name or field path. There we go. Why isn't that working? Oh, it's because it's of type V. I think I need to implement this on each subclass. So for reindex, I need to call super reindex, and that'll clear the other tree. detected. Of course, we'll have to change that later if we actually want to hold on to the other fields. So that works. For other index, if you remember, what we need to do on this one is for each one of these records, we need to check to see if the tree already has it. And I wonder if I need to do a like a compute with the other tree. Might be kind of nice to do that. So let's just see if it contains the other key. We'll just do it the long way for now. So this is the key for that particular record. We want to see if the tree contains that key. We need a list of V. What is this? List of D. Values equals new. No. Let's see. May have to do this a little bit differently. Let's do this a little differently. So if it contains the other key, we need to do a get from that key and add at the end this record. Otherwise, if it doesn't contain the key, I know this is like a double lookup here. That's why I think that we need to have like a compute. Because if it doesn't exist, we'll need to create a new one. Wait, what am I doing? No, I need add key. There we go. So if it doesn't exist, so if it does not contain the key, then I just add this key associated with a new list. I know that this could be a singleton, but I don't want to, I did that. Does it make it immutable? No, it returns a singleton list implementation, which I can't do that because this is going to grow over time. And this one I think is mutable. Come on, load. Yeah, it just returns a new array list. I guess I can just do that. Oh, it's because it uses the array. Yeah, that's fine. I'll just do it like this. So that reindexes. So then if I go back over here and I reindex this person list, and I put a breakpoint right after that. Kind of want to see this in action. I don't need that breakpoint anymore. Here we go. So the first name index is a unique index, and that should have failed. Right? Oh, probably because I have age in there. Let me comment that out because I know that I have repeated first names. So apparently that was unique, the combination of the age and the first name. So let's go ahead and restart that. And this one should fail if I implemented that correctly. Oh, that didn't fail. Why didn't that fail? Let's take a look at the other leaf node. Because with my unique index, my re-indexing is just always adding that record to this key. Yeah, so my leaf node, I bet I have something in there. Let's take a look at the add. Yeah, what to do if a non-unique key? I should probably throw a unique key constraint violation, right? Let's just create something like that. Key. I mean, this is going to be a runtime exception. No reason to force people to catch that exception. And let's go ahead and build a message for this. There we go. So that should fail. And because I changed the BTree, yeah, unique key constraint violation, found duplicate key, and I did that key. Nice. So I should also run the BTree test. Is this the... Yeah, this is the correct one. Just to make sure it's still... Oop, see? Yeah, there's the unique key constraint violation, found duplicate key 2. Where is that? Yeah, I was actually testing specifically for a duplicate key. So repeated key. Repeated key. So here is the repeated key. I guess I should do this as a separate test, because I think the BTree has to be unique keys. Yeah, so let's wait. Repeated key, BTree, integer string tree equals new BTree. 60 doesn't really matter because I'm going to be breaking it. Move this test down here. Let's do tree add 1. Yeah, let's just do 4 and I equals 0, I plus, or it's less than 5, I plus plus. Just do this. Do that. All right. So now we can assert throws. And this is going to be this throwable unique key constraint violation class. And my executable is going to be tree.add 2. So then now we're guaranteeing a the unique key constraint violation exception to be thrown if we repeat a key. All right, there we go. So that takes care of that. So I can close those out. I can close that one out. And this one, we do have that unique key constraint violation. That's cool. So then if we were to come back to our test and we remove this unique and rerun that, we're not going to fail due to the unique constraint, right? But we have a unsupported operation. Why? What? But the array list, what? Didn't that return an array list? All right, so new array list. And oh, apparently that was a different implementation of array list. That's kind of stupid. Yeah, this is not the array list. This is a private static class array list. Yeah. I just saw array list and I just went from there. Yeah, I figured that one out. I mean, this way is stupid. So new array list. List of D list equals that. List.add record. And then this one, just add the list. There we go. So now if I run that, it's no longer going to get that exception. And we do make it down here. So we should be able to take a look at this first name index. And notice that it created it with the first name as the index name because I didn't specify the name. So I was able to take all of the fields and auto-generate a index name, just as it does in MongoDB. And then we have the fields, and we have our tree, and our tree, 5 degrees. We have a root. I mean, here we can actually see what it looks like. So watch this. This one's actually cool. So evaluate expression. I want to do a new graph viz outputter with that tree, right? To string, do that, copy the value of that, go back to my browser, go back to this, paste it, and there's our tree. Very hard to see, but that is our tree. Zooming in. That's as far as I can zoom in like that. Then I can do some extra zooming with the Mac zoom. And we can see that we actually have all of those keys. But because of the fact that we didn't care about the unique key constraint violation, we actually have a list. So notice that they're in brackets here. It's because it's doing a toString on the list, and the other list is looking like an array. So that actually is working. Let's find one that would have repeated ones, right? So let's come up here and see if we can find that. Or wait, this isn't values. Never mind. That's not going to work. Hey, Commodore 20 or 256. I just wanted to say Commodore 64. Love the Commodore 64. Thanks for joining the stream today. Yeah, I'm not printing values, so this isn't going to work. This is just printing the keys, so that should be fine. You have a difficult tech career path question. All right, I might have a difficult answer for you. Might be difficult for me to answer. So that seemed to have worked. It's really nice that I was able to do that well. So then it just returned the other index, which I still haven't figured out a name for. But if I put unique, it'll just try to do a unique, but it'll fail the first time that I have the constraint violation. So that's pretty cool that I can have the two different implementations. So I can probably expand upon this later based upon the type of fields that I have. I might have to do a special index that can handle text if I ever start doing like pattern matching inside of my strings. All right, so then I can hit play. I don't need a breakpoint there anymore, and I can finish up. So that did re-index. So that is kind of cute. So we kind of want to, we want to do a search, right? I just don't know how to do that off the top of my head. Something is going to have to take this selector and break it down into individual parts of how I'm going to query for this across multiple indexes. Like if I ever actually want to support index any kind of index intersections. So that takes care of that. I can open that up later if I ever need it. What if everything you liked about technology stopped existing and modern technology has become the antithesis of what made you interested in tech in the first place, and you don't want to work on obsolete relics? I hate our modern paradigm, but I like the specification. This that is a difficult question to answer. I guess what I would do, I mean, sometimes if you go to like conferences and stuff, they can sometimes rejuvenate. You can basically refresh yourself, because if you're just doing your day-to-day job and you don't recharge, you could get seriously burned out. I've been there a few times. Of course, I'm not loving previous technology. I'm glad that like Internet Explorer 6 is gone, and all of the stuff for Java, all of the new versions. That's pretty exciting, but it's really hard to say. I mean, what kind of technology that you liked back in the day no longer exists? Like MFM hard drives or ArcNet cards, token ring cards for networking. So you can't travel to conferences and have no tech job. Oh, so you don't have a tech job right now, but you're wanting to get into a tech job? I guess in that particular case, you would just have to think of in terms of what do you enjoy? I mean, if you're not in a tech job now, what sparks your interest? Are you thinking about doing programming, or are you thinking about more like IT work, working on networks, like a network administrator, thing like that? Not qualified to do anything, and even if I was, nothing aligns with my values. Yeah, I'm not entirely sure how to answer your question. It's a little on the other vague side. So it's hard to say. I mean, are you, whenever you're saying values, are you talking about like moral values or something different? Moral. Okay. Yeah, that one I really wouldn't want to dive into, because everybody has their own moral dilemmas. So it's really hard to say. I mean, if technology and science kind of go against your fiber as being a human, it's really hard for anybody to tell you how to bypass that, because that's a personal thing for you. All right, so if I create a index on first name and age, see, and that's where I think I need to pass the types into the key itself, because that's how it's going to do some of the other comparisons. I think right now I'm creating it in the test, which I can stop doing that. I can stop that in the other search range. So it's really, the key is owned by the index. I mean, heck, I would probably be able to throw this key as an inner type. Ooh, that is a long bit of text there. I liked how late 20th century technology respected the user and the idea that you can understand how anything works with a simple screwdriver. Now everything is so oh, I agree with that. Everything is definitely much more complicated. Like, I don't even build my own computers anymore, because whenever it got past a logical naming for processors and even GPUs, it's very difficult to know the comparisons on some of this stuff unless you're really into the hardware side. As well be in the late 20th century, no cars had cellular modems, resistor coil property. Yeah. Not necessarily. I mean, that's not necessarily true. I mean, programming, like, I don't do any kind of data mining or anything like that. It really depends on what you want to do. I mean, if you're a web developer, you can do that all without touching any kind of data mining. I mean, if you work for an organization like Meta or Google, I'm pretty sure that you're going to be facing some of that data mining. Yeah, I think that's a whole separate topic of like microtransactions, where basically your car has all of these features already built into it, but then you have to subscribe to actually unlock the features that you already have. And then even then, you don't even have ownership of stuff. It's like you can have a smart refrigerator, but you don't own the software that the refrigerator is running on, so you wouldn't be able to legally hack the software to do whatever you want to do. Yeah, I guess so. If you can drink at 11 a.m. I don't care if people do that. I guess it really depends on your coworkers in that regard. Yeah, I actually might use this key internally, my index. I'm creating the key here. No, I'm creating it like that. Yeah, let me private final. No, I don't need a final if it's not a static class. Complicated just to give devs job security. The rapid development model of the modern era encourages buggy code. That's true. Higher source lines of code, higher chance of bugs means that you get paid to support. Yeah, I think that's more of a culture thing, and every job is going to be different. And it also depends on what type of software you're writing. Because obviously certain types of software needs to be more meticulous in regards to what data is passed through it, or what the uptime needs to be. I mean, if you're writing code for like NASA or something like that, you can't really just throw a bunch of lines of code and call it a day. Every software development lifecycle is going to be a little bit different. Somebody with your frustrations. I think because what you were asking is a little bit more abstract. I think you would need to identify, do you even have a passion? I mean, are you getting into are you wanting to get into a tech job just to have a tech job, or is there something you're actually passionate about that you're wanting to get into? Because even from there, there's such a plethora of different subject matters. Like that's one thing that I enjoy about programming, is because if I don't like writing medical software, I can just go to a lawyer firm and start working on law software, right? Or if I wanted to work on like a networking stuff, I can go work for a telephone company, but still be able to program. So I don't have to change my base knowledge. But it really depends on which area of the industry that you're wanting to be in. So you enjoy more of the hardware side then? And sorry, Fitzer 1997. I'm not ignoring you. I'm working on a database specifically for running it in the browser using Java. In regards to the hardware question, I don't know. I have no idea how to answer you. I've never been a hardware guy myself. I mean, back whenever I was in college, I had a card trunk full of token ring cards, MFM hard drives, and a bunch of other random crap. I enjoyed just playing around building stuff like that. My roommate and I created a bunch of dumb terminals, and we did a lot of mudding and stuff like that, but multi-user dungeon, not dipping ourselves into mud. Doing leak code. I am not entirely sure what leak code is. Is that like some sort of testing website? IT recycling business. That'd be interesting. Oh, okay. I see what you're saying. No, this isn't, I'm not just solving random puzzles from a website. I'm writing a database for the other browser using Java. Working on indexing stuff right now. Well, sometimes you have to work on old computers to better understand how the newer ones work. Whenever I worked for an internet provider, I learned a lot about how like IP addresses work, how subnet masking worked. I understood how Ethernet packets worked, all of the 7 layers of the ISO protocol, all of that kind of stuff. So yeah, that was very interesting, and it helped with a good base foundation for all of the knowledge that I acquired later. So you want to learn Java. And how did I do it? That was like 20 years ago or more. It was a long time ago whenever I learned Java. Whenever I learned Java, I was working for a telephone company, writing provisioning software. It was actually a system written in Perl at the time, so I wrote a lot of Perl, and a worker and I decided to start migrating a lot of that provisioning. Like, by provisioning, I'm talking about setting up all of the Cisco routers, all of the voice routers, stuff like that, to bring up a customer service. So whenever you call like Verizon, for example, and say, hey, I need a new phone number, it would actually go through all of that provisioning process, where the software that I wrote actually logged into all of those remote routers, set up new accounts, stuff like that. Eventually it went to Java, so it was kind of a learning phase whenever I started doing that. Most of it was on the job learning, so I didn't do a lot of formal education around Java. My college, it was back in the day whenever they were still doing C++ in college. Back in the late 90s. Late 90s is a long time ago. Yes, I am an ancient learner. I'm old. Yeah, C++ is nice. I also did assembler in college. I hated assembly. We did IBM assembler. That was not fun. Peeking and poking at memory addresses, and ugh, I have nightmares just thinking of it. Yeah, it was terrible. It really was. I hated it. We didn't do a lot with it. I don't even remember why we were learning assembly. It was during, I think it was during my finite automata class. I can't remember. Learned a lot about lambdas that year. All right, so I'm converting all of this to a private class. I'm going to see what I can do about the private class because the key is really specific to the index itself, and I think this would actually help us in regards to which country are you from? United States. I'm actually in the Northeast. I used to live in the Midwest. Yeah, I'm just trying to figure out. Yes, New England. I actually live in New Hampshire, about an hour north of Boston. Yeah, I went here for the no sales tax and no income tax. That was a pretty nice benefit of living here. I don't know if I want to pull this out as a separate thing or not. I'm a little distracted. Because I was wanting to be able to go through all of the fields and use the fields for the positive, negative direction. Oh yeah, Nashua is pretty nice. A lot of people around here, since I've only lived here a couple of years, but a lot of people around here don't care much for Nashua. They call it Trashua. I don't think it's that bad. There's a lot of nice things about Nashua. I think it's because so many people from Massachusetts have come into the state to live on the southernmost side of the state. I don't know how I'm gonna do this. So what if I did this? What if I change this to key? Sort of, not really. Basically being able to create index data similar to MongoDB. So I was playing around with MongoDB earlier for basically loading a bunch of documents and creating indexes for faster searches. Because I would like to be able to, on the client side, if I'm driving like a select box or some sort of search that may have like 1,000 records or so, it might be nice to be able to search those in an indexed fashion. So last couple of weeks, I implemented this BTree for all of my indexing. So I'm using BTree. If you've ever played around with BTrees, they're pretty nice. There's a website that you can go to. Let's see, BTree visualization. It's University of San Francisco. So here's a BTree. This isn't exactly what, this isn't exactly, I'm actually wanting the B+tree. So let me kill that and see if I can find the B+tree. There it is, B+tree. So this is basically how I'm creating it. And let me move the controls to the top. So it provides big O log of n searching capabilities. So in this particular case, if I want to find 3, it's able to traverse all the way down. And the reason I'm using a B+ tree is because I didn't want the keys to be up here. I wanted all of the keys and the values to be on the bottom right rank, with a link list in between them, so that if I it allows me to do like ranges a lot easier, because then I can just go to the next node and find the one that doesn't. That way I don't have to keep traversing the tree to find the next one. So big O log of n search capability, not having to search an entire database of a couple of thousand records. So that is the whole intent with that. So right now I'm trying to create a comparable composite key. Yes. So that's the degrees. So if I this one's maximum degree. There's a pretty good Wikipedia page on this. This one has a maximum degree of 3, which means that you can only hold 2 records in a single node, and once it gets up to the 3rd one, it has to split off. So if I add, for example, a 6, we'll be able to see this one split, and then it pulls up a key into the previous one, and so on. So it constantly balances itself out, which is unlike a binary search tree, because with a binary search tree, you can still have a worst case scenario of big O of n, because if everything's balanced only on a single side of the tree, that's not very beneficial. But at least with a B+ tree or a B tree, it constantly balances. So that is what I'm using as the back end for my indexes. But right now I'm trying to figure out how to implement a key that's comparable, that allows you to set multi values in there, and specifically with how to compare them, ascending, descending. So here, I'm probably going to want a private final list of object key values. I'm basically going to copy all of this, but I'm just going to make a slight modification to the compare, so that I can iterate over the fields instead of the key values, because then I don't have to rely upon the key values. I don't know if I need to worry about the max value and min value right now. Only whenever I'm creating the ranges will I need those. So let's go ahead and implement this compare to. So my initial value is 0, and I could probably copy some of these comments. And for this one, I equal 0. So I kind of need the other fields entry set. No, I could probably just do values, because I only care about the type. Yeah, let me grab the values, types, field types. For int I equals, and I think it's because this is a collection, I'm not going to have random access to it. Yeah, I didn't think so. I need this as a list. that's not an array. Why did I do that? Let me just copy that. Get it to work first, optimize later. All right, so then the other field types. So the type equals field types, get index. I'm going to rename this one as that. So I have this and that. And object equals this, key values, get an I, and this has to be size safe. Right, because the premature optimization is the root of all evil, because too many people go down the road of prematurely optimizing something whenever it probably didn't even need it. Waiting for my question to be answered until you finish this. Did I miss your question? You're trying to make a key value. I already answered that one. Unless you just haven't asked it yet. Most likely it's silly because I don't know where the function is going. Yeah, feel free to ask anything. I'll try to answer best to my knowledge. Key values size is greater than I, otherwise null. This week I've already streamed twice. The other founder to my company, he streamed yesterday. All right, object B is equal to that key values size is greater than I. That key values get I or null. That would prevent, for some reason, if the key values were ever a different size, which they shouldn't be. Yeah, they shouldn't be, because this is a private inner class, so I can guarantee that those would never happen. So let me just implement it the faster way, because that's probably a Boolean expression that'll always be true. Sorry about that. Got some chatting in Slack. The stream's a little bit more busy than I'm used to. Imagine Java knowing that AOT, that a Boolean is always true. I'm not entirely sure what you're asking there. Most of this I'm just copying. I'm retyping it only because it's bringing in my my thought process. So if A is comparable but B is null, val oh yeah, So for Colin, I think he's lurking right now. The captions that you see are browser. It's a browser thing only. Oh, there you are, Colin. Equals 1. Yeah, I think I need to do this. So if val is not equal to 0, instead of returning, I just need to break. Because then down here, instead of just returning val, I need to check to see if type dot ascending or descending equals type. Oh, no, I need the field type. That one's a tough one. Let me think about that. Because this is accruing over all of these. And it's based on the other type. So nulls first. Let me just get back down to the next one. So I'm going to ignore these for the time being. Nope. Yep. That's what I wanted. So val equals comparable A compared to B. So the hard part is, based upon the other type, I may need to negate it. And I think that would be right here. So then if type descending, how does that work? That might be kind of weird. Well, I guess if you're thinking about it, if it's on the second, so if it does equals first, meaning that the value is equal to 0, it would go to the next one in the list. We don't actually get to the other portions of the key values until we find one that's not equal. And then if it's not equal, then we need to look for that particular column, that field, if we are ascending or descending. So in that particular case, then we'll just, if it's descending, we just multiply it by -1 and that'll work. So here, now if this is like not equal to 0, then I could just return that and that'll exit the loop. Otherwise, it'll return val, which will always be 0 if we got down to here. Yeah, that's true. I mean, I could always just breaks out of that loop and then just returns val. Then that val is not always 0. Yeah, that could work. So now just want to return a new key. And the uses of this, because this class is private, probably want this to be protected maybe. That way the subclasses can see it. That way whenever I'm adding that key, it's able to see that key. Yeah. Okay, that'll work. Let's see what this does. I don't even remember where we left off with our test. All right, so incompatible types. All right, that's cool. I forgot to update this class. Aha. That was simple. Let's go ahead and build that. Re-execute that. All right, I'm assuming that worked. I am assuming that worked. All right, cool. So the next phase of this, now that we've done that, I can ignore that. We can do a selector, and we don't want to do this anymore. Probably gonna get rid of that BTree, because the BTrees, see, now I'm like, probably need to rename my test, because now it's converting into a test on the index itself, which makes sense for me to do. So here it's like, I just need to search. But it needs to be a valid search for this particular index. I don't think the index should be in the business of splitting out the selector into logical parts. I think I'm gonna need a new class for like a plan something. What do we call it? Discoverer. Yeah, being at 4 hours into the stream with a small break, getting kind of tired. Query planner, something planner. Did I already create it? All right, so yeah, I got a lot of cruft to clean up. Because I guess I don't need this stuff anymore. I'm going to replace the original index with this new index, but I want to be able to search this index. But in order to search this index, I'm going to need something that's a little bit more sane, because if I get to the point of having any of these methods that do like an in, for example, the in operator. This will actually have to pull out multiple searches on that index BTree. And from that, it would do a union between the two. So in this particular case, I would search for all users with the first name Noreen, or users, all people with the first name Noreen, and then the age has to be one of 15 or 12. And in this one, I would probably want to split those into multiple fetches. See, and with greater than, this one's also going to be problematic because it's not just greater than. Right now it's implemented as a greater than or equal to. So what was my original plan here? Creating the index, do a search, create a search with that find. Yeah, I think I can just do a first person or first name index dot search on the selector. And that returns a result. I don't know if it's going to do a promise of a result or just the result itself. But let's go ahead and implement it this way and see what that looks like. We may have to implement it differently later. Oh, and we're also going to need a way to sort. But that might be at a higher level. It might be a part of the find. Because if I take a look at the documentation for MongoDB, where was my query at? Query documents, here we go. With the other query, I think you put sort information as a separate thing. Sort. I know that you do in here. So if I'm doing a find here, more options, I can pass the sort first name, right? And the direction, like 1 for ascending, -1 for descending. So I'm thinking that this stuff would be a separate argument to the find. So the filter is going to be the first part, and then the second part would be a config for the sort. And that's essentially what this search is. So I'm imagining how this is going to work. The find, whenever you pass it a search, it's going to plan that query. It's going to take a look at your selector to figure out which fields you're querying for, find out which index can handle that query. It might break it into multiple queries, but I want to be able to, within that query planner, break it down into something that the index can actually use. So the index wouldn't have to worry about the in queries. I think that would be up to the query planner to break that into 2 different sets. Possibly. But I'm not entirely sure if I'm going to be passing in the selector. All right, so then in here, search. See, this is where it's going to get weird. Because I kind of need that that other class that we created earlier. What was that? Search range? I'm probably going to switch these to, oh wait, I can't do keys. Because it's all self-contained in here. Let me probably copy this as a nested class 2. Do I need it that way? I guess that's not terrible. Yeah, I think that could work. So let me just create the same stuff over here. So we have the key for the start. We have a key for the end. These are not parameterized. Public search range. Selector of V. Is that right? And I'm just going to copy and paste these and change some of this after I import. I don't know if that's correct or not. I think I got really weird with my generics parameterizations. I guess I don't need to do that since it's a private class. All right. So if I search for the selector, let's just do a quick and reasonable search first. New range, select. What is that? Search range. And this is going to be the internal, passing at the selector of D. Oh, this is of D, not a V. So is this D2? I don't know if it is or not. I'm probably going to get a class cast exception. I need to remember what these are for. Range. So then BTree or tree dot search range, range dot start, range dot end, true inclusive. Guess I don't need to return the tuples on this, so I'm going to stream this. I'm going to map it to tuple get value. And here we will need to do the additional filtering, but I will probably do that later. Oh, yeah, that's the other problem. The subclasses, because unique index, this would work for the unique index, but not for the other, because we have collections. So let's just implement these individually. Need to do that. And then, the parent. So I will need to do this because it's no longer visible. That is not the right class. That's weird. Where's my search range? There it is. Oh, I guess that was at the end. Weird. That's weird. Why can't I see that? Tuple import. That was weird. I'm not entirely sure why that wasn't working. See, that one will work. However, the other index will not. And why is this not failing? Oh, abstract. Apparently I never made it abstract. That would have been a problem. All right, so here we're just going to want to do our search. Probably similar to this. Grab our range, but in this particular instance, this is going to be slightly different. We can't just return this as is. We will need to flatten. Flat map. How do you do that? It's another thing that I don't do too often. Java stream, flat list of lists. Oh, flat map list stream. Okay. There we go. There we go. That could work. I mean, I could probably pull some of this stuff out into the super class, and it's really just down to this point where I probably need to map into an internal function to further modify it. Probably need to do the same thing in regards to sorting as well. But I don't know if we're going to sort at the index level. I don't know if that makes sense. You don't have a list as a single operator on the end. Well, I do here. So basically, because this index is holding duplicate values, potentially duplicate values, on a per key basis, because let's say that you have a database with an index on first name, and you have like 20 people with the same first name. So in this particular index, my BTree is holding the value of a list of that object. So then whenever I index this tree and I'm adding things to it, I'm actually creating a new array list, adding that record to it, throwing it onto the tree with that key, and I'm done with it. If it already contains that key, I know it's already a list, so then I would be able to add this record to that list. So whenever I'm grabbing all of the tuples back, the value of the tuple for this particular key, like mark, it'll be a list of all of the objects that had the first name Mark. So then I basically need to flatten that by taking the stream of that particular list and flatten it to the outer list, and then I collect all of that as a single list. So kind of complicated, colluded. Like I said, I should probably pull this out into a separate method so that I can pull all of this crap up into the base class, and then each method or each subclass would have to implement a further mapping as necessary, or it just returns itself. Yeah, might not be a bad idea. Let's try that. You can do toList on your lambda instead of collect. Can you? I don't think so, because this is a yeah, maybe you can. Is that just a convenience? Oh, that returns an unmodifiable list. You probably want this to be mutable. So I guess it really depends on if you want it mutable or not. This one will create a mutable list, I believe. Since I don't know what I'm doing with the return value yet, I'm just going to leave it as a mutable list. But like I said, I can probably refactor some of this stuff out into the parent. And I can do mutate, or I don't know what I want to call this. Map to map. I don't know. Values. Stream. And for now, let's just do let's do this. And map values is going to be a protected method that's going to return a stream of D. Map values, and this is going to take a stream of T. Or V, sorry. V stream. For the unique index, maybe I should just do this as an abstract method. And then in my unique index, I can just return that D stream because it's already the D. And then for the other index, map values, I can return list stream flat map list.stream, and that will flatten that map. Cool. So then I can remove this, and I can remove this and I consolidated. I could probably do a filter and a sort as separate methods too. So that could work. Because if the search, and this is, I don't know, I might change that. The sorting might be something different. I need a better name for that. Let's go ahead and run this again. Cannot be cast to integer. All right, so this is a compare. I think it's because I have something weird. Oh, that's right. Haha. It's because I pulled in the logic for max value, didn't I? I did right there. I shouldn't have done that. Yeah, this is stupid. Private. I need to really clean up my code base to get rid of all of the extra stuff in here. So here, instead of doing that, I can do that. I guess I wasn't ever using min value, was I? Oh, I am. I guess not in the other key though. So let's go ahead and update this with that. If b is max value, val equals -1. Else if b equals min value, val equals 1. Else that one. All right. Well, does that work? And it does, I'm assuming. I don't know what it actually returned. So I don't think I printed it out. No, I did not. I don't need that anymore. So let's iterate over the other result. And let's just print this person. See what we got. And the results is empty. Awesome. Let's find out why it was empty. So I'm going to move this over here so I can see it a little bit better. Because most of the stuff seems to be going into this base index. We're only overriding necessary methods. So here in the search, I want to put a breakpoint there. Kind of want to see what my range is. My start is going to be Noreen and 15. So then the the end should be Noreen and I probably need a 2 string, but this is a max value. 4.5 hours into the stream. Well, let's see what happens. We did the tree search range start, range.end, inclusive. Does this return anything? It returns 0. Yeah, we do have values. My key is name and age. First name and age. Yeah, I mean that should have worked, right? Let me look at my key again. So here's my key. I'm doing a compare. I wonder if it has anything to do with this. Let me execute that again and see if we get there. Yeah, we do have some descending. So that shouldn't be a problem. So what I'm going to do in my test over here, let's just see what this looks like. So let's do a sub list of the first 20 records, and from that, tree. I'm gonna have to make that public. Actually, let me just do debug. And then in here, let's implement our debug. Let's system out a new graph viz. That's weird. Where's that graph viz? Oh boy, that's because this is in the client, not in the other core. Should have probably moved that. No, it's in core. This is also in core. Oh, it's because it's package private. Yeah, let's just make it public for now. And here is my graph viz. And I can come over here to my online viewer and paste that in. We should at least see the first 20 records. I'm going to expand my window so I can see it a little bit better. Oh, I don't have a toString on this. That's fine. Yeah, that's not fine. I'm gonna need a toString on my key. All right, let's rerun that. should have our names in it, names and ages. Yeah, I mean, this looks correct. See, Lorette is right there. Margot is right there. Sylvain is right there. Yeah, the structure seems correct. So what is wrong here? Yeah, I mean, that seems correct. I think I've just been going at this too long. Yeah, so the start is Noreen 15. And the end is Noreen maximum. I wonder if it's, it's probably because of the field sorting. Because the comparator, that's going to be a problem. Yeah, if I were to do min value here, probably need to choose min value versus max value based upon the search direction. I know that seems really stupid. I bet it'll return something on this time. No, it did not. Why didn't it return something? Let me change my index to not do descending. Let's just do ascending first. I think the problem is with the descending. This is the right max value, right? Yeah. I need to get rid of that debug. Oh, that's still not working. Why isn't that? Didn't we test this like at the beginning of the stream? This probably has to do with the compare though. Let me put a breakpoint here. And then I can come in here and put a breakpoint. Yeah, I don't need that. So in here, I'm comparing. I want to go there. -2. So negative means that this one is less than this one. That's correct. Where did that breakpoint do this one? All right, so this is -1, which means that this one is less than this. And that's correct. Alphabetically. Do this one, it's 5, which means that this one is greater than this. That is correct. Come in here. This one's 3. This one's greater than that one. That's correct. One's greater than. That one is less than. That's greater than. And then what? Oh, it's because we forgot to remove that sub list. All right, yeah. I mean, almost 5 hours. I could probably ignore breakpoints and just hit play. Probably need to stop debugging that. Oof, that's a big collection. Yeah, here's my results. Yep. Has to do with the index giving a descending on age. Okay, so let me put that back. So type descending. And then in my search range, let me just change this to min value. I think that is the other problem. So let's comment that out and run that. And that should still return it. Return 1 that time. I need to create a toString for that. And I only want those 3 for now. So that is returning nothing. Ugh. And this, which ones is this returning? It's returning 12, which is less than 15. Even though that was greater than. I don't know. Yeah, being almost 5 hours into the stream, my kids are actually going to be home from school soon. I am going to go ahead and call it for today. Didn't get as far as I was hoping, but I did solve a lot of problems. I'm going to keep hitting away at this, see if I can at least get between now and the next time I stream, which most likely will be next Tuesday. I'm going to try to clean up some of this stuff. I might get rid of the old index. I'll have to see what is using it. I may be able to get rid of it. You know, we are using like the add and remove because the database is still using the indexes to do this stuff. I might have to add some of those methods to the new index so that I can actually migrate away from this old index. Yeah, these are all using promises though. Can't remember why I was using promises for this. Yeah, why was I doing init with a promise? Because if I'm creating a new index, I mean, I guess that's allowing it to index on the side, not being in the same, but I think it needs to be in the same execution thread. So I don't know why I put that in a promise. Yeah, I think we'll I think I can clean this up without changing too much stuff and make it confusing for the next stream, but I'm going to go ahead and call it. I appreciate everybody that came out. We had some pretty good discussions in chat earlier. I know that some of you have been using me in the background, which is perfectly fine. I will be back on Tuesday, hoping. So I will see you then. Have a great weekend.